Welcome to online classes of Malabar Engineering College. Now I am taking class for S6 Automobile and the subject is Machine Design 2. Okay. Now the topic I am going to handle is a simple problem based on the disc brake. Actually, what is meant by disc brake? Disc brake is usually used in a two-wheeler automobile system in which a brake is there, like in a form of a disc. There will be a disc rotating, there will be two pads, and when the vehicle should be stopped, the wheels should be stopped. For the wheels to be stopped, the disc will rotate and the pad will be, some pressure is applied on the pad and it stops the brake. Like that, the pad is stopped and the vehicle wheel is stopped. Like that, it goes like that. Okay, we are going to discuss a simple problem based on the disc brake. Okay, let's see the problem. Following data is given for the caliber disc brake with an annular pad for the front wheel of the motor vehicle. Like the front wheel of the motor vehicle having the disc brake, and the torque capacity is given as 1500 Newton meter, and outer radius of the pad is 150 mm and the inner radius of the pad is 100 mm, and coefficient of friction that is given as 0.35. The average pressure on the pad is 2 megapascal MPa. Number of pads used is 2. Now what we need to find in this problem is to calculate the angular dimension of the pad. First of all, let me show the arrangement of a disc brake system. Here there is a center is a disc brake and this 2P applies the force. These two are the pads used in the disc brake and this is the side view, and when we look to the front view of it, cross-sectional front view, we can see this is the disc and this is the brake, and this is the brake pad applied, and the angle made here, theta, the angle dimension of the pad, this theta is the one which we should be found in this problem, and the distance from the center of the disc to the inward radius, that is Ri, and distance from the center of the disc to the outward radius, that is Ro. Okay, this is how the components of in a disc brake system. Okay, now let's first step, let me write the given data. Okay, let's write the given data. First we have the torque capacity. It is notated by the letter MT and it is 1500 Newton meter as given in the question. Then comes the outer radius, that is around 150 mm. Then the inner radius Ri is equal to 100 mm. And then PA is the pressure, that is average pressure on the pad, that is 2 MPa. And then the coefficient of friction, that is 0.35 mu, and the number of pads used is 2. Okay, first of all we need to find the actual force inside this, that actual force what is applied, that is we need to find the P. Okay, since there is two brake pads are used, we need to find the torque capacity is 1500. So for 2 it is like around 1500. We need to divide by 2 to find the brake capacity in one pad. So it will be like 1500 by 2, that is in Newton meter. The force that is applied is in Newton meter. Then after that we need to find the frictional radius, and it is given notated by the letter RF, and its equation is given in the data book, 2 by 3 into RO cube minus RI cube by RO square minus RI square. By substituting the value of RO is 150 and substituting the value of RI as 100 mm, we get the value of the friction radius RF is equal to 126.67 mm, that's the value. And then we have another equation, MT is equal to mu into P into RF. Okay, the MT is we have in the question 1500 and we take the half of it, 750, into the unit is Newton meter, so we need to convert to mm, so into 10 raised to 3 equal to the coefficient of friction mu, that is given as 0.35, and after that pressure P we need to find, and the RF value we had found in friction radius, that's around 126.67 mm. By substituting we get the value of pressure, like the force, that force is 16916.85 Newton. The unit we get is in Newton. After that, the question, we need to find the angular dimension of the pad. Okay, for angular dimension, P is equal to average pressure into area of the pad is the equation. Okay, we found the P is equal to 16.85 is the value, and average pressure that we have, average pressure on the pad is 2 MPa, megapascal. We need to convert this megapascal to Newton per mm square. That is, megapascal is equal to Newton per mm square. While we convert, the same values come. So it will be like 2 into the values given by 2 MPa into, that will becomes 2 Newton per mm square into area. Here the value which is unknown is for area, and we find the value of area. Area will be like 8458.42 mm square. That is the value for the area. Then after that, we have another equation in the data book. Using that equation, A is equal to half into theta, the angle, theta into rho square minus ri square, and we substitute the value of rho square is equal to 150 mm and ri square value is 100 mm. By substituting, we know the area 8458.42 mm square, and here we can find the value of theta. That theta is the angular dimension of the pad. The value which we get here is in radians, so we need to convert to degree. The value is in angle, we need in the degree, so we need to take that radians is converted to degree by multiplying with 180 by pi. So the angle we get is around 77.54, and by rounding the value we get around 80 degree, and that's how the value 80 degree is the angular dimension of the pad used in this disc brake. I hope all you understand. By this I wind up today's class. Thank you.